Geometry Chapter 7, Lesson 4, and we're going to be looking at similarity in right triangles. Now, we've looked at triangles recently that are similar. Once we were able to show that the triangles were similar using AA, SAS, or SSS similarity, we were then able to use the proportion of the sides, or that similarity ratio, to then determine the lengths of maybe a side that was missing in one of the two triangles. We're going to do much the same thing, but we're going to look at what happens with that proportion when we're in right triangles, and there's some interesting things that happen. Now, before we take a look at the right triangle specifically, we want to take one more look at these proportions, because proportions where we have a mean value that's the same happens quite often in geometry. And you remember from when we set up our proportions that the product of the extremes is equal to the product of the means. Well, you'll notice if these mean values are the same, when we multiply these together, we get x squared is equal to a times b, multiplying the extremes and the means. Now, to solve for x, when x is squared, we have to undo that, and the way we undo something that is squared is we take the square root. So we take the square root of both sides, and that gives us the value of x, which is equal to the square root of a times b. So what that means is that the geometric mean of any two positive numbers is simply the square root of those two numbers multiplied together, because if I put them in a proportion and I put an x value here in the means positions that was the same, this is what it would simplify to. So let me show you a few examples of that. To find the geometric mean of 4 and 18, I simply know that the geometric mean, well, let me show you why it works the way it works. We could write a proportion, and the geometric mean, so these two values are the same, so the mean values are the same, the geometric mean of 4 and 18. So I put 4 and 18 in the extreme positions. I then simply solve this using the cross products, or the product of the extremes is equal to the product of the means. So then I take the square root of both sides, so I have x is the square root of 72, and then I would use my skill that I now have in simplifying radicals to come up with 6 square root of 2. So the geometric mean of 4 and 18 is 6 square root of 2. Okay? Now, you can shorten this process as far as, writing out the proportion and then actually doing the product of the extremes and product of the means by remembering that the geometric mean is equal to the square root of the two numbers multiplied together. So that's simply the square root of 4 times 18. And so then I would get here. Or you could set up the proportion either way. So let's look at one example here. Square root, or the geometric mean of 15 and 20. The geometric mean is the square root of these two numbers multiplied together. Now, I could multiply these together and get 300, and then do my prime factorization doing this. Well, I'm going to show you a little shortcut. If I multiply these together and get 300, and then I end up dividing them back out, it really doesn't make any sense to multiply something and then turn around and divide it, because dividing undoes multiplication. So rather than multiplying 15 and 20 together, I'm just going to prime factor each one of these separately. So 15 I prime factor into 3 and 5, and so I'm going to rewrite that here. And 20 I can prime factor as 2, 2, 5, and 1. So I have a 2, a 2, and a 5. And now these are the prime factors. If I multiply these together, this would equal 300. So you can see it doesn't make any sense to multiply them together and then divide it out, because you're just undoing what you just did. So better just to divide these out now, and then again I'm looking for two that are the same, because these two would come out as a 2, this 5 and this 5 come out as a 5, and then I have this 3 that's left over, so that would be 10 square root of 3 would be the correct answer. I'm going to do a few more examples just so you see how you can kind of shortcut this a little bit. What would be the geometric mean of 4 and 10? Well, the geometric mean is equal to the two numbers multiplied together, and the square root. Now again, I could multiply these together, but I'm just going to prime factor them. 4 is 2 times 2, and 10 is 2 times 5. Those are the prime factors. I can do that without doing that over here. So these two become a 2 outside. There's only one more 2 left, so it has to stay, and one more 5. So I multiply those together, give me 2 square root of 10, so this would be the correct answer. So what is the geometric mean of 9 and 24? So the geometric mean is the square root of these two numbers multiplied together. So I can rewrite 9 as 3 times 3, and then 24, if I'm not sure, I can go out here and do my prime factorization over here. So I have a 2 times a 2 times a 2 times another 3. Okay? So then I'm looking for 2 of the same thing. So these two 3's are on the outside now as 1. These two 2's are on the outside as 1. I only have one more 2 and one more 3, so I'll have to multiply those together. And so I'll multiply the numbers on the outside, so I have 6 square root of 6 would be the geometric mean of 9 and 24.